Hello, good morning friends. Welcome back to your favorite channel Code One Digest. Today in this tutorial, we will learn asynchronous message design pattern for microservices. Yes friend, I'll explain what is asynchronous message design pattern all about, where to use it, what are the advantages of this design pattern. I'll also give you the real world examples of this design pattern. So stay tuned and watch this tutorial till end. It is going to be very exciting and informative tutorial today. There is lot to learn from this video. Friends, in the previous video, we discussed about serverless deployment design pattern. Do you know what is serverless deployment design pattern all about? Can you explain serverless deployment design pattern? Provide your answer in the comment section of this video. If you have not seen that video, so please go and watch that video on Code One Digest channel. The link is provided on your screen and also given in the description section of this video. So for more information, go and watch the previous video on Code One Digest channel. Okay, friends?
He has an agenda.
Okay, friends. So here is the agenda of this tutorial today. I will give you introduction of asynchronous message communication design pattern. Then I'll explain you the challenges that we see with synchronous communication in microservices. Then I'll explain you various types of integration for asynchronous communication. What are various integration types available for asynchronous communication? Then I'll show you the real world examples of asynchronous message design patterns. Then we'll understand where to use asynchronous message design pattern. I'll also show you the benefits of asynchronous message design pattern. At the end, I'll be summarizing what we learned in this tutorial today. Okay, friends, so stay tuned and watch this video till end. It is going to be very exciting and very informative tutorial today. Right, friends? Friends, before we proceed in this video, I request you to subscribe this channel to grow Code One Digest family. Friends, I am creating a lot of quality videos on programming, coding concepts, design pattern and design principles, cloud and container technologies, but I'm not getting subscribers. I request you to like, share and subscribe this channel so that I can grow our Code One Digest family. Thank you.
Oh, I'm so excited.
Okay friends, so now let's start with asynchronous messaging design pattern for microservices. Let's understand what is asynchronous communication and asynchronous messaging design pattern all about. This design pattern is for the inter-service communication whenever multiple microservices wants to interact, wants to communicate with each other, then we apply this design pattern. This is a type of a communication design pattern. So remember, we are talking about microservices communication with each other. Hence, this design pattern is for microservice communication when multiple microservices wants to interact with each other, like many-to-many communication. So let's understand that. Before we start with asynchronous communication, let's spend 1 minute to understand synchronous communication. Synchronous communication is good for one-to-one communication and if sender expects the immediate response back from the receiving party. But when it comes to a several microservices wants to call each other, wants to interact with each other, and there is a long waiting time for the operation to finish, then in that scenario, we should use asynchronous communication. Otherwise, that dependency and the coupling of microservices will create bottleneck and create serious problem in the architecture. Okay, don't worry, I'll explain you that in detail. Always remember, there are two things is important in software architecture: divide and conquer and loose coupling between the components. We have achieved divide and conquer with microservice architecture. As we have divided the monolithic application into small services, hence we have achieved the divide and conquer to make it a small application, small services. Now we can achieve the loose coupling in our architecture via asynchronous communication. Hence, asynchronous mode of communication is very important in distributed applications, in cloud-based applications, or in microservice architecture. These are the very important and key feature of software architecture that we should use divide and conquer to divide big application into small services and to achieve a loose coupling between the components. Right, friends? If you see the microservice architecture has become increasingly popular in modern software development due to their flexibility, scalability, and maintainability. However, as with any distributed systems, communication between microservices can become complex and error prone. Actually, microservices are distributed systems running on multiple processes. Services required to interact with each other using inter-process communication protocol like HTTP sync, gRPC, or async AMQP protocols. With synchronous communication, the caller sends a message and waits for the response from the recipient. In synchronous communication, sender is blocked till it gets the response back from the recipient. This approach is useful when the caller needs immediate response from the recipient, such as during the login or a purchase flow. In contrast to synchronous communication, asynchronous communication allows the caller to continue working without waiting for a response from a recipient. This is often preferred when the caller does not need an immediate response, such as sending notification like SMS, email for registration, or order confirmation in online store, etc. If you want to interact with multiple microservices without creating dependencies or tight coupling between them, so consider using asynchronous communication in your microservice architecture, which is commonly referred as a event-driven communication. By using events, microservices can communicate with each other in loosely coupled manner without being directly tied to one another. Asynchronous message-based communication provides a flexibility and scalability to the microservice architecture. Hence, it makes microservice architecture popular choice for the developers. If we have a very few interaction with querying microservices, then we should use HTTP request response with resource APIs. But when it comes to busy interaction in communication across multiple microservices, then we should use asynchronous messaging platform like message broker system. In asynchronous communication, the AMQP protocol, the producer sends a message and does not wait for the response from the recipient side. It only sends a message and expects that it will consume by subscribers via message broker like Kafka or RabbitMQ. If you have multiple microservices required to interact with each other, and if you want to make them loosely coupled, then we should use asynchronous message-based communication in microservice architecture. Because asynchronous message-based communication works with events, so event can place the communication between microservices. We call this communication as event-driven communication. Also, event-driven communication brings eventual consistency into our architecture. You would have noticed that when multiple microservices calling each other in synchronous mode of communication, so they form a chain of requests. This makes microservices tightly coupled with each other. And this is a major pain point of microservice architecture, and this is an anti-pattern as well. These need to be fixed and redesigned using asynchronous communication. Given the same scenario in asynchronous communication, multiple microservices communicate with each other over the message broker like Kafka or RabbitMQ. We can either use queues or publish a subscriber pattern with message brokers to achieve asynchronous communication. Publisher subscriber or a queue both have their own use cases and applicability, and we will see that in a while. Okay, friends, clear? Okay, friends, so now let's understand some limitations of synchronous communication and why do we need asynchronous communication in microservice architecture. So let's understand the limitation first. Synchronous systems are tightly coupled. Example, when a caller service calling recipient service, so caller service wait for the response from a recipient service. This is a good scenario in login registration flow where we expect immediate response from the system. In a synchronous communication, any problem in downstream service can have an immediate impact on a caller service. Example, service S1 calling service S2 and service S2 calling service S3. So any failure in service S3 would cascade back to the service S2 and service S1 as well. Hence, it impacts the working of service S2 and S1 as well. Therefore, we use the circuit breaker pattern in synchronous communication to avoid the cascading effect to the calling services. Right, friends? Addition to the cascading effect, retry from the caller service to all downstream services would amplify this problem in the synchronous communication, right? As the downstream services are already down and retry would create more problem in the microservice architecture. Right, friends?
What the hell are you talking about?
Okay, friends, so now let's understand the various integration patterns that we have for asynchronous communication. The first one is publisher subscriber model. Publisher publishes the message on a topic and subscriber subscribe for the topic. In this model, event broker sends a copy of each message to all the subscriber of that topic. Right, friends? Second is message queues. There can be one or more publisher for a queue and one or more consumer of that queue. But important point to remember here is one message goes to only one consumer. You may have more consumers of that queue, but one message will be consumed by only one consumer. So in this setup, one message will be consumed only by one consumer. We use this mode of communication for parallel processing of messages. Example, when you want to transfer data in especially in ETL jobs, when you transfer the data from one system to other systems, then you need a lot of processing. Hence, you want to improve the performance, you want to do that job faster by achieving the parallel processing. In that scenario, we use the queues and add more consumer for the parallel processing. We use this mode of communication for parallel processing of messages by adding more and more consumer to process more data in a queue. More consumers you add, fast processing the data from the queue. Because one message will go to one consumer, and if you have 10 consumers, so 10 messages will get processed in parallel. Third is many to one communication. In this setup, you may have multiple publisher and there will be one and only one consumer going to receive all the messages. Fourth is request and response. After a consumer processes a message, it sends a reply to another channel so that producer can find the result. Okay friends, so now let's understand the asynchronous message pattern with some real world example. Let's understand this pattern via publisher subscriber model. In publisher subscriber pattern, publisher publishes the message and subscriber service will receive the messages. Subscribers subscribe to a channel or a topic they are interested in. We use PubSub for many to many or one to many or fan out or broadcast type of communication. Use the PubSub model when multiple system wants to receive same messages. For example, when user submits a form, and you need to update several databases or send notifications or update other APIs with that information. This pattern also allows you to add new functionality without interrupting or changing the existing one. Like in example of form submission, we want to start sending SMS notification to users. Hence, you can define a new subscribers for sending SMS notification for a form submit event. Receiving an event, SMS subscriber will send SMS notification to user. This enhancement does not impact other subscribers or system. New subscriber can subscribe to the channel and start receiving messages and perform new action. Let's discuss this with an example on your screen. In this example, publisher P1 sending message M1 to a channel and all subscribers C1, C2, C3 have subscribed to this channel. Hence, all subscriber will receive the message M1. Now let's understand this with an example of e-commerce site. The scenario where user places an order on online store. So what all system would be interested in receiving that order event? Let's understand the sequence of action by multiple systems for order event. Publisher. So order service is a publisher and order service places the order for a user and send order event on an event broker like Kafka or RabbitMQ. Now subscriber one is email notification service. On receiving order event, email notification service sends email message to user that order is submitted for the processing. Subscriber 2, inventory system. Inventory system gets the order event and puts those items on hold while the payment is completed and to prevent someone else is buying the same item. Subscriber 3, payment service. On receiving order event, payment system sends the payment request to the payment gateway. Subscriber 4, profile service. On receiving order event, profile service adds the order on order history page. And subscriber 5, analytic and monitoring service. On receiving order event, analytics systems updates the order analytics. So there can be n number of subscribers for the same event. Hence, this is the ideal case where we should use the publisher subscriber model and we should use the asynchronous communication. Right, friends? Let's see one more example of IoT device like a thermometer measuring a temperature and multiple systems are interested in receiving the temperature reading. So publisher, that is thermometer publishing a temperature measurement on a topic every few seconds. And subscriber 1, that is reporting system. Reporting system subscribe to the temperature event and receiving each temperature event, it updates the few metrics into a reporting database. Now we have another subscriber that is alerting service. Receiving a temperature event, an alerting service aggregates the temperature reading in a time window, and if the temperature is stay too high for a too long time, so it sends the alert message to weathering system. Right, friends? There are multiple parties who are interested in receiving the same message. Hence, in this scenario, we should use the publisher subscriber pattern for asynchronous communication. And there are various message broker available in the market to support publisher subscriber model. Like you have RabbitMQ, you have ActiveMQ, you have Kafka, you have Nets, you have AWS SQS or SNS system, you have Azure Message Bus, then you have Google Publisher Subscriber, and then you have Anypoint MQ. And there are many more available. Right, friends?
Oh, wow. That's amazing.
Okay, friends. So now let's see another example of async message pattern using message queues. What is message queue? The message queue pattern is very common pattern and used for the worker queue, message groups, consumer groups, queue groups, competing consumer, and for point-to-point channels, etc. Producer pushes a message on a queue and consumer consumes the message from the queue for the processing. We can have one or more consumers reading the queue, but one message will go to one consumer only. That is, one message cannot go to multiple consumers. Always remember. In case of queues, one message will go to any one of the consumers. It will never happen that one message is given to multiple consumers for the processing. That is the basic idea of having queues. Okay, friends? So message queues are the great for distributed processing across multiple machines. Queues has many benefits, taking the load off from the front-end service. It allows massive horizontal scaling by adding more and more consumers on the other side of the queue and elegantly handling the load spikes. If there are not enough consumers to process, messages remains in the queue until the consumer processes it. So to scale out, we have to simply add more and more consumers. Another important difference between the queue and publisher subscriber model is the consumer of a message from a queue must acknowledge back to the message broker that message processing is completed. If consumer does not acknowledge the message after some time, the message broker service will think that the consumer failed processing and message will re-queue again so that another consumer can process it successfully. Let's understand queue with an image diagram on your screen. Publisher P1 sends message M1, M2, M3 to a queue. Consumer C1, C2, C3 receiving the separate messages from the queue. That is C1 receiving message M1, C2 receives message M2, C3 receives message M3. No two consumers receive the same message unless there is a failure or retry where the message has to be requeued or replayed. Let's understand this pattern with a real world examples of image sharing website. Users upload images to a photo sharing site, and those images need to be processed into various sizes and formats. Consider that there are millions of users using this site to upload their images. What would be the sequence of actions from the various systems? So, first is publisher, that is image upload service. Image upload service uploads the image to a temporary location in AWS S3 bucket and publishes a message on a queue. Now assume there are 5 consumers listening on that queue to process the images. Consumer 1 reading the message M1 from the queue, it converts the image into a various format and resizes the image appropriate for the storage. Then it applies some filters to adjust the colors and finally store it at the target location in S3 for other systems to use. Finally, it sends an acknowledgement back to the message broker that the image processing is completed successfully. Now consumer 2 reads the message M2 from the queue and performs the same task, resizing the image, adjusting color and storing it to a target location and sending acknowledge back to the message broker. Same way, all 5 consumers doing the same job by processing the different messages from the queue. During the festival season or holiday season, when more users uploading the image, we can scale our system by adding more consumers, that is up to 20, 30, 40 consumers, to process more images coming from the users. Hence, we get advantage of using queue into our distributed system, distributed application, and we can scale horizontally by adding more and more consumers to add more power to consume more and more load from the users. There are various message broker available to support queues like RabbitMQ, ActiveMQ, Kafka, NATS, AWS SQS SNS, Azure Message Bus, and Google PubSub and AnyPoint MQ. Right, friends?
That was amazing.
Now let's see some of the use case of this design pattern. Where to use asynchronous message communication design pattern. So use this pattern to decouple your microservices. Whenever you have microservices interacting with each other, whenever there are multiple microservices involved into a communication, hence use asynchronous messaging system to decouple the microservice. Use this pattern to achieve scalability to handle more load by adding more consumers for the queue. Use this pattern to achieve reliability so that if the consumer is not available for some time, hence the messages are stored safe in the queue. Use this pattern to achieve testability. If you want to test certain scenarios, you just have to add that message into a queue. Consumer service will receive it and process it accordingly. Right, friends? Now let's see some of the benefits of this design pattern. What are the advantages we get out of asynchronous messaging communication design pattern? First is scalability. Unlimited scalability if we use asynchronous message based communication approach, as we can add as many consumers we want to achieve parallel processing. Second is loose coupling. As we use asynchronous communication system like message broker, we are decoupling our microservices from each other. The failure in one service would not impact the other services. Third is reliability. With synchronous communication, if our service goes down, the communication will be lost. In contrast, asynchronous communication will process all the messages even if the service goes offline for maintenance. Message that cannot be processed will be stored into the queue for replaying it later. This ensures that messages are not lost. Fourth is testability. Testing individual microservices requires adding messages to the queue and ensuring that the consuming service behaves as intended. Additionally, it makes the testing easier and enables us to input many different permutations of messages, allowing us to test the service in various circumstances. As there are a lot of advantages of asynchronous communication, but there is a flip side as well. There are disadvantages of async communication, like it adds the complexity into our architecture and also add additional hops between the microservice communication. Right, friends?
Wow, that's amazing.
Okay, friends. So now let me summarize what we learned in this tutorial today. So I gave you introduction of asynchronous messaging design pattern. Then I explain you the challenges that we see with synchronous communication systems. What happens with request response model when one service is calling other service directly. There is a tight coupling, there is a cascading failures and so on. Then we understood the various integration types for asynchronous communication like pub sub model, like message queues and so on. Then I explain you the real world example of asynchronous communication by using publisher subscriber model and messaging queues, where we saw placing order into online store or sending the temperature reading to various systems, or when the user wants to upload their images for the processing on photo sharing website, right? So all these examples we saw. Then I explain you the usage of asynchronous messaging design pattern, in which scenario, in what circumstances we should use asynchronous message communication. Then we also understood the benefits of asynchronous message communication, like it offers us loose coupling, scalability, reliability, and more testability. Right, friends? So if you like this video, give it a thumbs up. And if you're new to the channel, so do subscribe to our channel to grow Code and Digest family. I hope you like this video and you understood what I am trying to explain in this design pattern. If you have any doubt or if you have any feedback for this video, please do write me into a comment section. I will definitely reply to your concern. Right, friends?
This is not rocket science.
Friends, if you like this video, so give it a thumbs up and subscribe to this channel for the more interesting videos. Click on the bell icon for the latest video notifications and do not forget to share this video with all your friends and colleagues. This is very useful information for students, beginners, and software engineers. I am putting a lot of efforts in creating these contents, so please help me growing the Code One Digest family. Please subscribe to Code One Digest channel for the latest programming and technology related videos. Thank you.